The essential question for this entire course is, what is everything made out of? It's one of the things a chemist tries to figure out all the time. One way of answering that question is to organize matter into types. And pure matter can be thought of as, well, various things, but we could divide it into two types. We'll also take a brief look for the first time at some chemical structures. We'll understand what an isomer is. And one really neat place to start is to take a look at four of the most abundant elements in living systems: hydrogen, oxygen, nitrogen, and carbon, and see how many bonds they typically form, and see how quickly from that we can come up with lots and lots of useful structures. And then we'll take a stab at what we know so far about that question, what is everything made out of? This is Screencast 1.5. What's everything made out of? Well, let's take a bunch of substances as examples and try to figure it out. You might recognize this one: some water, some salt, some milk of magnesia, and other various substances, and let's figure out what's in them. Okay, there's water. There's some sodium chloride. There's some milk of magnesia. Chemical name? Magnesium hydroxide. It looks like champagne and beer and wine and some scotch perhaps. These are all examples of substances that contain ethanol. They're not pure ethanol, but they contain ethanol. There's a substance in rotten fish that's really viciously smelly. It's known as triethylamine. And there's a flavor principle in almonds that gives them their odor and to a certain extent their taste. It's known as benzaldehyde. Okay, molecular formula for water, I'll bet you know it. H2O. Sodium chloride, I'll bet you know it. NaCl. Sodium chloride. Magnesium hydroxide, well, magnesium is Mg, hydroxide is OH. We'll need to put two of those OHs on. Perhaps you already know why. Ethanol is a carbon-based substance with an alcohol functionality. Formula: 2 carbons, 6 hydrogens, and an oxygen. Notice that some of these show you a little bit the arrangement, others just show you how many of each. Here's just how many of each type of element is in triethylamine: 6 carbons, 15 hydrogens, and a nitrogen. Does that tell us all we need to know about this substance? Hardly. And benzaldehyde, C7H5O. Those are molecular formulas, the amounts of each element. Here's the chemical structure for water. There's various ways you could arrange HHO, right? 2 hydrogens and an oxygen, but we'll see that it's always arranged like that. And notice how they make it bent. Sodium chloride, sometimes you see just a line there for the chemical bond, as are chemical bonds there. Other times they put a plus and a minus to define a certain type of bond. Magnesium hydroxide might be drawn like this, or it might be drawn like this. Just a line. We'll later learn that's called a covalent bond, or a plus-minus arrangement. Those are for ionic bonds. Ethanol. That's how that thing is arranged in space. Boy, there's a lot of ways you could combine those 9 different atoms, but in this case they're arranged like this. Triethylamine also could be arranged many ways, but it's a symmetrical alignment of a nitrogen in the center with 2 carbons attached to each side with various hydrogens filling up those bonds there. Benzaldehyde has a ring structure with alternating double bonds, and a carbon doubly bonded to oxygen. We'll later learn this is known as an aldehyde functionality. These substances can be divided into 2 groups. These groups here don't have a carbon in them. We call those inorganic types of substances. Every one of these does have a carbon in it, as do we. And that's the organic substance there. So matters can be either inorganic or organic. Now consider this. Let's draw 2 different substances. Butane, notice it's a linear 4-carbon hydrocarbon, and isobutane, which has a lower melting point, lower boiling point. This is the same number of carbons, but it's branched. Notice it's the same number of hydrogens as well. In each case, the molecular formula is C4H10. This is designed to show you that just because something has a formula doesn't mean it shows you its explicit chemical structure. both of these are C4H10. When you have the same chemical structure but a different arrangement of the atoms in space, we call those isomers. And I hope you're noticing that throughout this, hydrogen, oxygen, nitrogen, and carbon always contain the same number of bonds. As in any topic in chemistry, there will be exceptions, but this is largely true. How many bonds on hydrogen always? How many bonds on oxygen always? 1, 2, 3, and 4. Leading to that saying, honk if you love chemistry. This ends Unit 1.